Hello everyone. Today I'm going to talk to you more about how to write and earn an A on your lab report. So over the course of the semester, you're going to be performing 12 experiments and writing 10 lab reports. You may be wondering, what's the point of writing a lab report? Well, as scientists, whether you're in academia or you're in industry, one of the most important parts of being a scientist is writing up your work and analyzing your results so future scientists can replicate and then build upon your work. If you're not interested in a career in science, um, medical professionals, doctors, nurses, are also involved in scientific work. So recently in my research, I've had to read several papers that are written by medical doctors about clinical case trials. And in this case also, you need to be able to write up and detail your results for other people to read, but also to, in theory, replicate. And so one of the purposes of writing up each of your experiments and then combining these reports into a final paper at the end is giving you practice for being able to effectively communicate um, your findings as a scientist. Now, because you'll have 10 lab reports that are spaced over the whole semester, there'll be plenty of opportunity to receive feedback and then improve your writing. So by the end of the semester, you can do really well on your final paper and hopefully improve your writing in general. So now I want to take you through step by step a previous successful lab report that earned 100% and talk to you about the elements and some tips and tricks to help you write a good report. So the first aspect of a lab report is your statement of purpose. And your statement of purpose is pretty self-explanatory. In this case, this would take the place of an abstract or an introduction if you are writing a traditional journal article or lab report. And so in your statement of purpose, you're essentially describing the purpose of your experiment. So what is it that you're doing and why did you do it? And so in this particular lab report, the students split up experiment 1 and 2 instead of combining them, but whether or not you want to do that is up to you. And so you can see here they talked about how they needed to understand how to use a pipetter, how they measured the accuracy and precision of the pipetters, and then they talked about accurately preparing buffers. The next section is the materials and methods. And so in the materials and methods, this is where reproducibility becomes important. Because in the materials and methods, you're supposed to describe your experiments so that another person could replicate them. And the guidelines say that you should keep this to between 3 to 5 sentences. Your materials and methods really shouldn't be less than 3 sentences, but there may be some cases where it may be appropriate to go in depth um, as to more than 5 sentences. However, that's up to you. And so you can see here for this experiment, this person has a pretty good length for their materials and methods. An example of where perhaps a little too much detail may have been added was when they talk about weighing out the CAPS acid. You don't have to say specifically how much you weighed out as long as someone can take the molarity of the solution to back calculate and figure how they would remake the solution, if that makes sense. And you can see here that they've referenced the type of software that they've used. They've referenced buffer concentrations. And that is about the level of detail that we would be looking for. And so I'll also post an example of an effective materials and methods for you to look at and peruse and then help you write your own materials and methods. So the next part of the lab report, and this can be one of the trickiest parts of a lab report, honestly, and that's the results section. And in the results section, the purpose of this section is to summarize the results that you obtain from the experiment. And so this is going to contain graphs, plots, figures, pictures, tables, and any other form of analysis and results. And for any table or graphic or graph that you include in your lab report, you need to also include a descriptive legend. And the idea is that in theory, I should be able to look at your lab report and understand your results just from looking at your graphs and your tables and your pictures. So throughout these labs, you're going to be completing multiple calculations, and you may have to repeat the same calculation for multiple solutions. You'll see in this lab report, you'll see in a minute, they put in every single calculation they did. You don't need to put in every single calculation. You just need a representative of each type of calculation that you perform. Yes, one per calculation. And so you can see here, they have a table where they describe the table legend right here. They describe what the table is. So this is the experimental data of the accuracy and reproducibility of the pipettemen. There's the example calculations. Part B, again, example calculations where they go through and they show how they made the buffer. Okay, for table 2, effective buffer dilution on the pH as well. And then if we go into experiment 3, we can see their first figure. So where they describe what the data are. So this is an absorbance versus time for the LDH assay. They list the dilution factor. They say which replicate is which. So the gray line is the first replicate, the blue line is the second replicate, and then they say what the initial velocities are. Another important aspect of, with this graph, you can see that they have both the X and the y-axis labels, and then if applicable, they include the units. So in this case, the units for the time is minutes, and absorbance doesn't have a units. And when they mention the initial velocities in the legend, they include the correct units, so absorbance per minute. So when you go in and you're making your graphs and you fit your data, if you are applying a fit, you need to make sure to show the fit on top of your data. And you also need to include the equation for the fit, as well as the R² value to show the goodness of the fit. So when you're making your legend, when you're making your figure, the keys for the good figures are your labels, a descriptive legend, include all correct units, show your fit, and with your fit, be sure to include the equation as well as the R² to give us an idea for the goodness of the fit. All right. So another part that makes the results section challenging is that it may be tempting to just copy and paste your figures and then do all of the talking about your data, and so do all of the describing of your results in your figure legend. And that's not what we want you to do, because if you're writing, the ultimate goal is to be able to write a scientific paper. That's what you're going to be doing at the end of the semester. And if you were to pull up a scientific paper, in fact, I can go ahead, I can pull one up right now. All right, so here's a scientific paper. If we go to the results, so this is a results in a discussion. So in this particular case, it's combined. We're not going to do this for this lab. You can see there are literally paragraphs and paragraphs of text that describe their experimental results. And so when you're writing your lab report and ultimately your final paper, you also need to do the same. And so in your results section, there needs to be a point where after you've included your figures, or before, however you want, you need to reference your figures and then talk about the results that are in the figures and then briefly summarize your results and what they mean. So if we go back up to the first part of this experiment, so in their results section, they've included all their figures and they've included all their calculations, but you can see we have text here where they report the values, they report the average deviations, and they say whether or not those values are accurate. We include some text here where again they talk about this particular pipetter. And then in the second part, they also talk about their results from the activity assay as well. So when you're writing your lab report, you need to make sure to include all your figures and tables and calculations in your results, but you also need to provide a textual portion where you describe and then talk a little bit about your results before moving into the discussion. And it's the discussion is where you're going to be answering your big questions. So in the discussion section again, try to cap it at 5 to 6 sentences, but if you can't, so be it. Use your best judgment. Don't take up a whole page for the discussion. But when you talk about the discussion, whereas in the results, you're going to be summarizing your results and telling us what happened. In the discussion section, you're going to be talking about why these things happened, an explanation, why does this matter? And then also, if your results seem a little fishy, something went wrong, the discussion is where you're going to talk more about what could have possibly went wrong. So again, you describe the underlying principles behind the experiment. Specifically, you answer any post-lab questions that are posted in the handout. So usually we'll say at the end of the lab handout, we'll give you the questions that you're supposed to answer in the discussion to help guide you through. If you answer those questions in paragraph form and you put thought into it, you will do well in your discussion section. But then finally, you have to go beyond and you really have to describe the broader impacts of your result. Why does this all matter? Because as a scientist, nobody's going to care about your paper if you don't sell your audience on why it matters. Nobody's going to give you grant funding for more experiments if you don't show why your work matters. And so the discussion and also the impact statement at the beginning are where you're really going to pull people in and convince people that your work is important. And the same goes for this lab report and the paper at the end of the semester. Another thing I'd like to note about how to get an A on your lab reports and to do well throughout the semester is to take feedback. So throughout the semester, you're going to turn in your lab reports in Google Classroom. Lindsay is going to grade them. I'll take a look and I'll include comments as well. And you're going to notice that especially on the first few lab reports, you're going to get a lot of comments back. And they may be on formatting, they may be on the way you approach things, they may be on how you set up your tables or your figures, and with a point value that's deducted. And one of the quickest ways that you can get a better grade in the future and get a better grade on your final paper is to take note of those corrections, immediately incorporate them into your report and save it as a modified document, and then take note of those changes and make sure you don't make the same mistakes on your subsequent lab reports. That will increase your grades on your lab reports, and it's also going to help you write a final paper. Because remember, at the end of the semester, the idea is that if you do a good job and you keep up with your lab reports, that you can take your materials and methods and your results sections, copy and paste them, and make the materials and methods in the results sections for your final paper. And then also you can use your discussion. You can format your discussion and take your ideas from your lab reports and make a more formal discussion in your final paper. All right, that's about what I have for now. So if you have any questions on your lab reports, please feel free to contact me or talk to Lindsay as well.